We're going January 2018, Jack. Okay, I'm ready. 28, everybody. 28. Okay. Very good question. Okay, right from the get-go, here's where I'm going to start with a formula is not on the reference sheet, but it is on your cold hard fact sheet that you need to know a week from Friday, and that is the area formula of a sector. Okay, area formula of a sector, which is the following. Measure of the arc over 360 times pi r squared. Okay. That's one we got to come in knowing. If not, hey, hopefully they don't ask it. All right, before I get to how to involve this problem at all, it says determine and state the number of degrees in angle Q. So this is really what you're looking for right there. Okay, I need to plug in for R, and I need to plug in for the sector over here too, the area of the sector. But here's the problem. If you read through it, Jack, they don't give me the area of the shaded one, do they? What do they give me? Right here, the unshaded. This is what they're giving me. All right. So here's my plan. I'm going to use this with this formula. Okay. So what I'm going to say is what was the area of the unshaded part? So I'm going to say 500 pi is equal to this formula. I'm going to put an x in for the measure of the arc over 360 times pi. What's my radius, Jack? 25 squared. Now, will this get me my final answer? No. What is this going to get me? It's going to get me this angle right here, the other part of it. But what can you do with that, Jack, to get to angle Q then? Okay, we got a plan now. All right, so I'll help you guys solve this here. What do I have already on both sides I can get rid of, so make my life a little easier? Pi's can go on both sides, so I'll be left with 500 equals x over 360 times, what's 625? 23rd. What would be your next move here to solve this? There's a couple things we could do. Yep. You could do that too. Yep. Another way. But then, Sam, you're going to have to plug it into this form. What you just told me will get you the area of this right here. Won't get me the answer. The answer is what's the angle Q. So what you could do is what you just described to me, but plug it in here now. And then say 25 pi. That's fine. Yep. But I'm back to here. What are you guys doing here? Thomas. Okay, multiply both sides by 360. That's fine with me. Get rid of the 360. And now you just have 625x equals to whatever that number is. I'm not too sure. And then divide both sides by 625. That's your angle. And then, like you said, Jack, subtract it from 360. Anything else from parts 2 and 3 of that exam? Because that's what I suggested over the weekend. Anything else for parts 2 and 3? Again, you guys know the rules. Don't ask me because you didn't do it. And don't ask me because you want to see if you got it right or wrong. Anything else? Parts 2 and 3? Go ahead, John. 27? Yep. All right, 27, I have a right triangle where C is the right angle. And then I have A and B. And you are comparing the sine of A versus the cosine of B. Okay, a couple ways. One is actually plug in angles. Okay, because you know I already have a 90-degree angle. A and B have to add to what? To make 180 degrees here. 90 degrees. So you could do it right. You could say, all right, let's pick 50 here and 40 here. Okay, so we could go ahead right now and do, all right, sine of 50 is equal to whatever you found. Cosine of 40 is going to be equal to, and these are going to come out to be the same. Okay, they're going to come out to be the same because when the angles add to 90, they're equal. So now your next one you pick is sine of A is going to increase now. So I go sine of 50. All right, how about sine of 52? And then pick cosine of 30. They don't have to add. All right, just as one goes up, the others goes down, and you show that those decimals are increasing and decreasing based on this. Okay, the other way, which would probably be a little bit better than just showing a bunch of decimals. If the sine of A increases, or you could answer that if it increases or decreases by doing that. But when are these equal? When their angles add to 90, right? Okay, so think about it. If I keep increasing this angle here, what's got to happen over here? Whoa, whoa, whoa. Like that's 50. That's got to be 40, right? To make a match up. Now this will be, I keep increasing, 60. This has got to be 30. So as one goes up, the other one's got to go down to make sure they equal to 90. Okay, so you could show it that way too. All right, because for them to be equal, they have to add to 90. So as I increase one of the angles, the other one's got to go down. Okay. Anything else? Parts 2 through 3. Okay, go back to the proof. June 2018. I want correct stuff written down right now, please. Go back to the proof. Because I didn't get to check hardly any of yours. I want to make sure we have the correct stuff written in, specifically the reasons. Here's how we left it. I left it with you Friday. I said, prove the triangle's congruent. So here's what you have to have in your, I don't know what step it is. I'm totally making this up. I'm just going to start randomly with step 5. I'm going to prove the triangle's congruent. Here's what should be in your proof. Angle A is congruent to angle C. Take a look, everyone. These two angles have to be congruent. Your reason, parallelogram implies, what property am I using there? Opposite angles congruent. Then somewhere in your proof, you should also mention that side BA is congruent to side CD. Right here, take a look. Gram implies, what property did I use there? Opposite sides congruent. Now, I saved this last one on purpose. They put those in there, right angles. Did they put them in your statement's reasons for you? No. No. And then that's what we're grading. We're not grading how well you mark up your diagram. So just because it's marked already, don't assume it's already in your proof. I still need to go through the 2 steps. First saying, hey, angle BFA is a right angle, and angle DEC is a right angle. Perpendicular lines form right angles. And then say they're congruent. All right angles are congruent. So that's how we get the triangles congruent. And I'm going to ask you guys by what method here. So triangle AFB is congruent to triangle CED. Anybody got a method why? What did we just show, John? Angle, angle, side. And remember why we were proving them congruent? Remember, we had these sides parallel. We were going to try to make them congruent. So now which segments are congruent in these two triangles? Get there. AF congruent to EC. AF congruent to EC. This was a long step proof. CPCTC. And then what did you guys have to do to these two here? Subtraction. Make sure, though, before you wrote subtraction, you have AD congruent to BC. Okay, AD congruent to BC. I'm going to put it right here. Same reason. AD congruent to BC because parallelogram implies opposite sides congruent. And then you show me subtract. We're almost done here. Show me subtraction. What am I subtracting? EA minus BC minus EC. So BC minus EC is equal to AD minus AF. Subtract. Guys, what has always come after addition? Substitution. That's not going to change. And if I could spell it right. Substitution. And then now you can say BE and FD are congruent. All right, here are the last two important steps. BEDF is now a parallelogram. Why? How? The wording is important. Go ahead, Nika.
Same pair of opposite sides and parallel.
One pair of opposite sides, congruent and parallel implies a parallelogram. And then what do we talk about on Friday? How do you make a parallelogram into a rectangle? Show it has a right angle. Where's that? You guys choose. Where do you want the right angle to be? Because I can't use these. These two are not in the parallelogram. Use a different one. Where am I going to put them? BFD. BFD is a right angle. I could probably stick that in this reason here because it's got the same angles. So BFD is a right angle. Want to write an extra step? That's fine. The reason is going to be perpendicular lines form right angles. And then finally, yes, step 14. I think it was a 14 step one, depending on which one's in. BEDF is a rectangle. All right, again, what's the wording going to be here? Not because it has a right angle. It's a parallelogram with a right angle. Implies parallelogram. That's what we're looking at. I have no idea what type of proof it'll be, but this is what it was last year for Geometry AB kids. Nam, go. Thank you. I even need to be checked sometimes. Thank you. Parallelogram. Not going to argue parallelogram, but yeah. Not what I needed here. All good. All right, I still got 5 minutes before I let you guys do what you got to do. So here we go. Stick on that exam, please. Stay with that. Here we go. Number 17. January 2018. Oh, we're on January 18. January 2018. Number 16. Colored pencils, highlighters, all allowed in the Regents. They've been all year long. You know, if you want to bring any. I didn't put it in supplies because they're not required, but if you want to bring pencils and highlighters. All right, circles. We weren't, it was a tough unit. The question asks which one is not true. So you're looking for the false one here, the false one, not true. All right, let's discuss. Is ABC a right triangle? What do we think? And be better back ourselves up. Don't give me the old, we are way, way beyond because it looks like it. Do we think ABC is a right triangle? It is. Where's the right? Go ahead, Emma. Sorry. Oh, easy. For start to you in a second. Where is the right angle? Angle. ABC. All right. Emma, why is it the right angle? What is? What is? I need more. You're missing something. Why is diameter is a right angle? There you go. So that is the right triangle for the false one. All right, kids. Do you think ABM is a isosceles? Do we be able to back yourself? Is that isosceles? Isosceles has two sides. Madeline, where are my two sides? Because those are radii. Radii are always congruent in a circle. Good job, everyone. So that's a true statement. Need a false. All right, now it gets a little tougher. Is arc BC the same measure as angle BMC? What did we call BMC? Are equal. All right, I get it. By process elimination, it's number 4, but why? What's wrong with number 4? What type of angle is ACB? Inscribed. What's the rule for inscribed? Half the arc, right? Well, looks okay. Whoa, whoa. What's the rule? Half the what? Half the what? Everyone see that? It's got to be half of the arc. All right, half of the arc. All right, not half the angle. We good there? I got one more I'm going to do with you, and then you're good to go. Oh, boy, here we go. Number 23. I know some of us aren't in this spot yet because we haven't reviewed enough, and you got more than plenty of days to review. Anybody turn to the page, saw the diagram, and knew exactly what we're about to do? This diagram right here, I give myself a right triangle on here. This is automatically Hills and Sass. In this, either this type of diagram or I see altitude drawn to the hypotenuse in the directions, Hills and Sass. All right, which one do I use? This is right triangle hypotenuse. For hypotenuse, right triangle, which is how long? So in H, I'm going to put 12. What's the L in Hill? Original C. Well, we're finding BC. From same one angles. And here's where they see that 8. Oh, let's plug it in. I'm good to go. The S stands for segment. There are 2 segments, CD and DA. Which one do we want? Anybody remember? The one next to the leg being used. So if I'm talking about CB, I want to use segment CD, which is not, you can find it pretty easily. How long is CD? CD, 4 units. Everyone all right there? A little review of Hill's pass. All right, let's keep going to finish this. X squared equals 48. Take the square root. Look what they did to you. Nasty. They left their answers in simplest radical form. Anybody know the biggest perfect square that goes into 48? It is 16 times 3. So we're looking at here, square root of 16 is 4, radical 3. Now, whoa, before, did you really need to know how to break 8? No, everyone's going to have a calculator, correct? Can you find the square root of 48 on your calculator? And then you can go over here and type in which decimal matches. Okay, so is this, you have to do it? No. Okay, you could have just seen which decimals are. Okay, questions? Okay, we are going hardcore here for the next 17 minutes. Okay, I'm going to walk around. I'll answer any questions you have. Just a little, something little. Ones to go online. Answer a quick flip of your packet to see if you got the correct answer for the multiple choice. Okay, you can look at all the videos are. It's your call. This is a review session now for the next 17 minutes with me here. And if you're going to work with somebody, that's fine. You can move around.